Ahoy hoy, we're back with episode 26 of The Core of Everything. Today we're going to be focusing on Mars, the fourth planet from the sun, seventh in size and mass in our solar system. It has a reddish tint in the night sky due to its iron oxide surface, which we'll get into in a bit. It's the Roman god of war, but also loved a bit of farming as well. So he was quite ferocious, but also like planting vegetables and tending to his crops.
Coincidentally, the name Mark comes from Mars. Actually, I think comes from the Roman god of war. I don't know if that's accurate for me.
Well, as I've told you before, I think you're the least confrontational bloke I think I've ever met. So maybe you're more on the vegetable
On
side.
the farming side, yeah.
You're more on the sort of like asparagus kind of side.
Yeah.
Anyway, Mars is second closest to Earth after Venus. But Mars, importantly, it has clouds, roughly a 24-hour day, seasons, polar ice caps, volcanoes, and canyons. So very similar to Earth. And billions of years ago, it may have even been very similar to Earth if it had a warmer atmosphere than now, which it would include lakes, rivers, and possibly oceans. Obviously, there's been a recent discovery, which we will get into in 5 minutes or so. Just a brief overview of the geology of Mars. So, similar to Earth, scientists have used seismometers to detect a core, mantle, and crust that makes up Mars. The crust is a volcanic basaltic rock, and some of these seismometers also record Marsquakes. So not earthquakes, as we'd have here, and these are on Mars, they're Marsquakes.
And
Now,
just to recap, the basalts are just kind of rocks that form at the surface. They have very, very small crystals because the lava cools very quickly. And they're normally these very dark black rocks that you might see in Iceland or Hawaii.
But you also you also know that there's sedimentary rock, right, on the surface of Mars.
Yes, that's true. Yeah, we might come on to this in a bit when we talk about water, but from the images that we've seen from various rovers and landers on Mars, and you can spend hours looking at the galleries online, NASA and other space agencies have loads of pictures, and you actually see these really nice, smooth, flat rocks that look like they have layering in them, and these are sedimentary rocks. So yeah, we got a bit of both.
Is that like a mudstone or a sandstone?
Yeah, those kind of things that might form in like a lagoon, for example.
Of course. Yeah. And I suppose as well, basalts get worn down themselves and become sedimentary rocks, don't they?
So, and that's the beauty of the rock cycle. Someone said to me the other day, someone who's been on this podcast actually, they said that there's no such thing as a sedimentary or a metamorphic rock, that all rocks at their core are volcanic. I think in my heart I disagreed, but I was struggling to articulate in that moment.
It depends on what point of the rock cycle you take it from.
But they were saying that volcanic rocks just get broken down into sedimentary rocks, and then metamorphic rocks just get changed. But I reckon some metamorphic rocks, like if you've got recrystallization, but then it comes to like the question, what is a rock?
So refer back to episode 1.
That's what I said to her.
Yeah. Yeah. Was it Benicia?
Yeah, it was.
Yeah.
But I love that, she's asking the deep questions we need to ask in geoscience.
Exactly, yeah. Well, but the nature of a rock cycle means that there is no start or end. It's continuous loop, isn't it?
Yeah. But I think her argument was there is no cycle because it's all volcanics or igneous.
But how can she describe carbon-rich rocks or...
Yeah, I brought that up.
So like a limestone isn't volcanic.
Yeah. I don't wish to rebut her arguments here because she's not here to defend them.
She can come on for the third time and actually defend herself, can't she?
Yeah. And if any of the listeners want to weigh in on this, then please do message us and let us know which side of the debate you're on. But you were talking about Marsquakes.
Oh, yeah. So, of course, yeah. So, as we've discussed before, earthquakes on Earth form plate boundaries because Earth's crust is made up of rigid slabs. Whereas at Mars, we don't have plates. So how are Marsquakes generated? And they get generated through meteorite impacts, it's been known, volcanic activity. So Olympus Mons, which is currently not active, but in the past, the movement of magma within Olympus Mons' magma chamber and beneath the crust, the movement would create pressure and friction that would build up this sort of strain energy that would get released as a Marsquake.
I think we talked about this before on the podcast, but Olympus Mons, the largest volcano in the solar system, 25 kilometers in height, and about the size of France, I think. Like, that's its surface expression. But you think about the size of the magma chamber underneath that.
Well, for context, Mount Everest is 6 miles,
Yeah, about
6 miles high.
just less than 9 kilometers.
So it's almost triple,
That's crazy.
almost triple the size, which is it would be like a nipple on Earth, wouldn't it? If you were to look at it. I love that analogy. It's an Earth with a little tiny little. Anyway, so yeah, Olympus Mons, so volcanic activity. There's also, although the crust of Mars is just one rigid slab, when Mars cooled, it contracted, which formed cracks around the crust with these faults, as we discussed before, which have cracks, but with movement either side of them.
Mm-hmm.
And within these cracks, pressure builds, and when they slip, this pressure is released as seismic waves, which could be also producing Mars quakes.
Mm.
And using a seismometer from NASA's InSight spacecraft, which landed on Mars in 2018, there's papers published in Science, I think, confirm from these seismic waves that Mars has a molten core. So you remember what we said about Earth? It was you have a seismic wave that travels through Earth's structures, and the different materials that it hits, it gets refracted at different angles. And the way it gets refracted and the speed at which the wave travels through the material means that we have different layers. And from this seismometer on the NASA's InSight spacecraft, we can see that we have this molten core. So Earth has a molten liquid outer core and a solid inner core. It's still not known if Mars has that solid inner core. Still uncertain, but it definitely has a molten outer core.
I guess one of the reasons why we have a solid inner core, because you think like center of the Earth is so hot, which is why we've got that liquid outer core. But the reason we have that inner core, my understanding is that the pressures are so high that like it's being compressed. And I wonder whether because Mars is smaller than Earth, that it's not produced those pressures to produce a solid inner core. Right. But I mean, we don't know whether there's one or not. So I'd be interested to know what the models say.
It could be small. It could be like a little Malteser.
That would be nice, wouldn't it? Just a tiny little ball of iron and nickel.
Yeah, exactly, yeah. So very similar to Earth, Mars has these layers. And also similar to Earth, there's been recent discoveries of water on Mars.
Yeah, exactly. So we had the InSight lander that landed on Mars in 2018. So this was kind of effectively a stationary lab that would send seismic waves down into Mars. So these kind of waves of energy, and look at how these waves were refracted, so kind of bent or reflected. And they, using the data from this, they have discovered liquid water deep in the rocky outer crust using a seismometer. But there is general evidence, there's other evidence we have for large volumes of water on Mars more than 3 billion years ago. So we think that kind of in these very old ages, I think it's called the like Noachian or something. We on Earth, we've got things like the Cretaceous and the Mesozoic and the Carboniferous, and Mars has its own designations, but they're a bit different to Earth because its geological history has been different. So we think over 3 billion years ago, Mars could have looked quite similar to Earth with water. So we've got frozen water at the poles. A lot of that material is also dry ice, so solid carbon dioxide. But I think they potentially think there's like salty waters kind of hiding beneath those ice caps as well. There's vapor in the atmosphere. The atmosphere is very, very thin. And this was actually really challenging for the Ingenuity helicopter that they sent there in 2020 with the Perseverance mission, because they had to design a helicopter that could fly in a very thin atmosphere. But there's some traces of vapor in the atmosphere as well. And then there's evidence for various kind of aqueous processes on the surface. So things like channels that have been incised down through the rock by rivers, and ripples. So a bit like if you go to the beach and you're in that like shallow bit, and you get all those kind of like ripples in the sand below your feet that get preserved over time.
So we're talking about rivers on Mars that have we can see now that there are rivers, and we know which way the water was traveling at
Yeah,
that time.
often these ripples can kind of give you an idea of flow direction. Or
Amazing.
sometimes, they might be symmetrical on both sides, which suggests that might have been like a tide that was kind of swashing in and out, and so makes them symmetrical. And we think like a lot of this water was lost by atmospheric escape. And this is all tied up with the geodynamo of Mars and its magnetic field, that when kind of the geodynamo stopped working and we lost this magnetic field, it was exposed to high energy kind of radiation, effectively the solar wind, high energy particles from the sun that basically just stripped away its atmosphere. And then if you've not got an atmosphere, you haven't got pressures, so all your water effectively just boils off the surface as well.
Do we know why the geodynamo stopped working? Because it has that molten outer core, like the Earth does.
Yeah, I don't know. I think there are papers suggesting it's something to do with its cooling history, and
Right.
maybe changes in the size of that outer core. I'm not quite sure.
Okay.
It remains a mystery, really.
So up until now, we have evidence that water existed, or liquid water existed. We have polar ice caps and we have vapor, but we don't have that magic middle bit. We don't have liquid water.
Yeah.
Until a paper this month.
Yeah, absolutely. So this was a paper off the back of that data from the InSight mission by Wright et al., 2024, published in PNAS, which is Proceedings of the National Academy of Sciences.
Making sure we emphasize the NAS.
Yeah, slightly unfortunate acronym, perhaps. So here they use the seismometer that we typically use on Earth to look at the layers of the Earth that we use for prospecting for oil and gas, looking at kind of different layers and different materials that are below our feet. And what you do is you look at the time it takes for these seismic waves to propagate through the Earth, hit the target that you're wanting to look at, and then reflect or refract back to you. And you look at the time that it takes, because you know the speed of your seismic waves. And this speed, this seismic velocity, is changed based on the material that you're looking at. So, for example, water, seismic waves travel at 1,500 meters per second. And then in igneous rocks like basalts, that's 6,000 meters per second.
So because basalt is denser, it's faster. A very simple way to look at this is very simple GCSE science, where you have distance, speed, and time in a triangle. Do you remember that?
What
and
a throwback!
D at the top and S for speed and T in the bottom right, and then you put your thumb over the D, which means distance equals speed times time. And then you put your thumb over the S, so speed equals distance over time. The point is, if you have the travel time for this refraction from going down into the hitting the surface and back up again, and you have the velocity, velocity, so water's 1,500 meters per second, you can calculate the distance, aka the depth of a layer of water or rock underground.
I love that. It all just stems from that early maths, doesn't it? So yeah, they did exactly this kind of thing, and they found that there was a reservoir of brine. So this is like salt-enriched water that you might get in your can of tuna, between 11.5 and 20 kilometers deep in the crust. And so what we're saying here is that we've got kind of this mid-crust that's composed of fractured igneous rock, and within that rock, it's saturated with water. So it's a little bit like a sponge, really. And this is a huge finding because, liquid water has been massively elusive throughout our solar system, aside from Earth. And we've looked for it elsewhere, and there's kind of models that suggest that it exists on some of the icy moons of Jupiter and Saturn. So moons like Europa and Enceladus and Ganymede that have icy crusts. And we think below those crusts, we've got liquid oceans, but we've not actually been able to observe it, and we've not landed on these places to kind of take the measurements. It's all been done from space,
except for the one Dawn spacecraft that had showed that there were similar briny waters, so very salty waters, on the surface of Ceres, which is the dwarf planet in the asteroid belt between Mars and Jupiter. And so the question is, where did this liquid come from? And the NASA Dawn spacecraft, a mission in October 2018, so it revealed these bright spots on the surface. Noted they were salt, so water rich in sodium, carbon, oxygen. that percolated up to the surface and evaporated. So it's like that. Remember those sort of, again, refer back to GCSE or even younger, used to put sort of water rich in different elements into a dish and leave it overnight, and the evaporation would cause these little crystals on the surface. And a similar thing is happening on the surface of Ceres. Using a gravity survey, which is calculating these density variations under the surface, they could see that briny sort of liquid most likely came from a reservoir rich in salt, 25 miles deep and hundreds of miles wide. So this is a potentially liquid reservoir. And it could be ongoing. Because we're in an asteroid belt, Ceres will be hit by lots of meteorites, lots of micrometeorites that hit the surface, causing dark spots on these bright spots. And so because of some of these bright areas of liquid, because they are undisturbed by any of these dark spots, it means that they must be extruding relatively recently. So it could still be ongoing.
It's remarkable because Ceres has a diameter of about 1,000 kilometers. In comparison to Earth, Earth has a diameter of about 13,000 kilometers. So it's about 13 times smaller than Earth. But has this.
Did you just Google the diameter of Earth, by the way?
No, I know the diameter of Earth.
I felt like you weren't listening to me for a second, so you just sort of looked up and went, "The diameter of Earth is 13,000 kilometers."
just want to get my facts out there.
No, you did know that. To be fair, go on, say that. Say that
I didn't know Ceres though, but just all that to say that Ceres is much smaller, but still has these processes going on the surface.
Yeah, it's Ceres stuff, isn't it?
Lovely. But I was just reading what I did find out when I wasn't paying 100% attention to my co-host, is that so when before Ceres was discovered, there were people who'd done some kind of like orbital mechanics and reckoned that there should be a planet or some kind of object at about where Ceres is. So 2.8 astronomical units are nearly 3 times the distance between the Sun and the Earth, about 420 million kilometers. And there was a guy in 1800 called Franz Xaver von Zach. He was the editor of the German astronomical journal Monatliche Korrespondenz, or Monthly Correspondence. And he sent requests to a bunch of astronomers who he called them the Celestial Police, which I love. I absolutely love that.
So quite a high crime rate, was there?
And he asked them to go and find Ceres. They didn't actually find it, but they found some other asteroids, Pallas, Juno, and Vesta. And actually, our asteroids are named after their technical kind of names. So Ceres is called 1 Ceres because it was the first asteroid to be found.
Well, let's hope there's more research and there'll be a Ceres 2. Let's move on to what in the world as our last little segment. Now, we mentioned like the Roman gods earlier today, and sticking with that sort of vibe, let's focus on Venus, the goddess of love and beauty, who is married to Vulcan, the god of fire. Vulcan being the god of fire, that is where we get the name volcano from. Originally, it was volcano with a U instead of an O. Possibly first used by the Romans, but it's not quite well understood when it first was used. So, for example, Pompeii, they didn't really have a word for volcano. Can
you imagine like the volcanoes exploding and they're just like, that thing.
They're like, yeah. Oh, the thing is like, what is it?
Big smoky thing.
Run away from the. I don't know, just run. Anyway, so Mars and Venus, goddess of beauty, remember? Mars had a love affair with Venus, even though she was married to Vulcan. And obviously, Mars and Venus are either side of Earth, so I don't know why they had to bypass Earth, put like a bit of a third wheel,
fly
a bit
around.
of a plump.
Yeah.
Yeah. Just like, can you imagine Mars just looking around Earth to Venus? But anyway, Mars was subdued by Venus's love. He did well. He's done well for himself, Mars, but he was sort of seduced by Venus, and in some accounts, Helios, the god of the sun, caught them in the act.
That sounds bad.
Having an affair. but in Homer's Odyssey, Vulcan found out. Maybe his ears pricked up because he's a Vulcan. Yeah. Homer described that Venus and Mars were exposed by Vulcan by trapping them in an invisible net.
Wait, by Helios?
By Vulcan.
By Vulcan, sorry. Yeah,
So,
there's a lot of characters
Homer
here.
described that.
Yeah, I'm there.
Homer described Venus and Mars were exposed by Vulcan by trapping them in an invisible net. And there's a lot of artwork which depicts this, including one by Botticelli that was done in 1485, which is now in the National Gallery in London.
Wow. That was good. That was great. We're branching out into the arts here.
I know. We should have a guest that combines both rocks and artwork.
And art, yeah. That's a fine
Isn't that
niche.
there's a Da Vinci painting, isn't there? Something on the rock.
David on the Rock? Whiskey?
A Virgin on the Rocks, maybe? We're not have Da Vinci on here, are we? Brilliant. Good job. So watch this space in terms of Mars. Really exciting stuff. And anyone that has watched science fiction or anyone that knows that old cliche, but it's not really a cliche. Wherever there's water, there's life. So at the moment, watch this space, because if we found liquid water, possibility there could be life.
Exciting stuff. See you next time.
Bye.
Bye.